Testing sound. No, you guys can hear me, but I can't hear myself in this. Can you guys actually hear me? Oh, wow, okay. This is strange. I'm trying to stream my... Oh, I think I know why. Give me 1 second. I just got to fix something. Switch account. Let's see. Any player. Okay. All right, guys. Hopefully you guys can actually hear me, because I'm trying to stream myself on my other laptop at the moment and I can't hear anything that I'm saying. So if anything plays up, just yell out in the chat if the sound goes funny or anything like that. Okay, so without further ado, I want to get started on today's kind of theme. Had two people kind of email me and they wanted me to do some quadratic inequations and some rearranging questions as well. Now, if you have any questions that you have, just pop it down into my just drop a comment somewhere and I'll pick it up and convert it into a little video if I can. Otherwise, you could always just reach out on my Facebook at Infinity+1 and just send a question there. Okay, so I'm going to work on these two questions first, and then after that I'm going to spend some time doing some rearrangement questions. Basically, let's actually get rid of this question for now. So this question is a bit popular, this whole quadratic equation and then putting it less than or greater than a value. It has different variations as well. Sometimes you might actually see it as a question like when is y always positive? Or sometimes they say when is y always negative? They also use sometimes when is the graph above x-axis and below x-axis. All right, so what that basically means is that it's literally the same question, but they just ask it in like 4 different ways. And so I'm going to use this one example and I'm going to show you guys what the answer actually looks like. Now again, if you're looking at this graph, this equation for the first time and you're thinking, geez, I got no idea where to start from, even though this is an excellence question, you can pretty much get up to merit just by rearranging and solving the quadratic. Okay, so sometimes, as I said, you get this, but also when is the quadratic above x-axis or below x-axis. All right, so to get started on this question, we have to rearrange everything first. So we've got x squared minus 7x plus 10 is less than -2. So rearrange it so that you have 0 on the right hand side. So I'm going to write this as x squared minus 7x plus 10 is, we got plus 2, and then that's less than 0. So what you have is x squared minus 7x plus 12 is less than 0. Okay, so we've got a quadratic equation and we're trying to figure out when is this quadratic less than 0. Okay, a couple of things to remember. Remember that this is a positive x squared graph, which, well, it's a positive parabola. So that means the parabola is going to look something like this, because it's a positive parabola. And we also know that it's going to have, we'll change the color. We also know that it's going to have the x-axis somewhere here. And we're actually trying to figure out when is this graph below 0. Now, when they're talking about below 0, so imagine it like this. You know, you've got the x-axis there, and then you've got the y-axis here. So remember, all the values of y above the x-axis is positive, and all the values below the x-axis is actually negative. And so right now, this is actually less than 0. So that means the zone that we're looking for, lovely, the zone that we're looking for is this zone right here. Okay, so now for those of you that are still going, geez, I got no idea what's happening in this question, just factorize the question and solve for the quadratic equal to 0. So my next step here is I'm gonna kind of skip a little line and just rewrite this as x squared minus 7x plus 12 equals to 0. So what I'm looking for is I'm looking for the solution for this particular quadratic. So I'm going to factorize it. I've kind of chosen a real nice easy one here. So two numbers that multiply to negative 12 and add up to negative 7. So it's going to be negative 4 and negative 3. And of course, then I can say x minus 4 equals 0. Man, that little taskbar is annoying. If anybody knows how to actually stop it from popping up, please let me know and I can kind of fix it. Then we've got x minus 3 equals to 0. So at the moment, I've got my two answers there, x equals to 4 and x equals to 3. All right. So just for those guys that, you know, if you look at a quadratic equation and you got no idea what the question's asking, sometimes I'd recommend you guys just to rearrange everything, rearrange a quadratic and then solve it equal to 0, because that usually ends up getting a achieved or a merit in some cases. Okay, so what do we do now that we have these two values 4 and 3? So now those 4 and 3, it's actually called the roots or the x-intercepts. So if I go back to my little parabola right here, this point right here is going to be positive 3, and this point right here is going to be positive 4. So in other words, this quadratic is below the x-axis between 3 and 4. All right, so now I know that in my last tutorial on last week Tuesday, I kind of just like rushed through this real quickly, but I want to spend a little bit more time on this type of questions today. So with this one, what happens is that we actually rewrite this whole thing. I actually say this, you know, whichever part is highlighted, that means put the x underneath it. So I literally draw the diagram, and then I put the x underneath the highlighted part, and then I write down 4, and then I write down 3. I'm literally just copying the numbers straight from down there, and then x is the highlighted part. So the only other thing that you need to remember is you need the symbols. So, and the symbols, you know, people have problems with this symbol, with the greater than, equal to, or less than or equal to. Basically, the sharp point is actually pointing to the smallest number. So that means I'm actually pointing it this way here. Now, it's really important that I don't actually put that equal sign below it. Just looking at some comments just quickly. Yes, whoever this person is, yes, it is live. But anyway, going back to this, so we don't actually put the equal sign at all. All right, so we just leave it as it is. The reason we leave it as it is because if you look at the original question actually says less than. However, if the original question actually said x squared minus 7x plus 10 less than or equal to negative 2, then your answer would also have that less than or equal to sign. Okay. All right, so what I'm going to do is I'm going to leave the screen up here, and I'm going to try and give you guys a question very similar to this so that you guys can actually try it. And I'm going to give you guys maybe about, I know it's a bit harsh, but 2 to 3 minutes. 2 to 3 minutes for you guys to actually give a go with this question. All right, so if you think, I'll leave the working up here for you guys, and I'm going to give you guys about like three or 4 minutes to try and work out this question here. So try this question here at the bottom. For you guys, I'm going to put down x squared. I'm sorry, I'm just looking for a problem. X squared, let's go with a nice simple one, eh? I hope that's going to work. No, it's not going to work. Will that work? Give me a second, guys. Sorry, I just want to double check that the questions work. The last thing I want to do is give you guys like questions that don't work, especially this late in the night. You don't want to be messing around with this. 6x minus 8. Yeah, that's going to be an ugly question. Give me 1 second. I'm going to change that to plus 9 and change that to plus 1. Okay, that should work. Let me just check. Yes, that question works. So what I would like you guys to do is, why is it pointing to 10 and not -2? Okay, I'll tell you what, why don't you guys work on that question, and then I will answer some people's questions on the comments. Raksha, that's because that pointing thing is actually pointing to the whole equation. So you've also, you don't just have the 10 there, but you also got x squared, -7x, and the 10. All right, so what it's basically saying is that that whole equation, the whole quadratic, is actually less than -2, not just the 10. Yeah, thanks, Lewin, for that. There we go. All right, so guys, there's a question at the bottom there. Just take about a few minutes to just give it a go. And then I'll actually go through the final answer for that. All right, and also if you are finished with that question, I'm going to give you a second question, which is going to look exactly the same, but except this time the symbol is going to be faced the other way. Jonathan, yes, it is working. I don't know if you just sent me a message. I haven't actually checked it yet. So look, I got something on Facebook. Why? Oh yeah, sweet. I'll have a look at that question, Jonathan, after this quadratic ones, yeah, because that is a nice quadratic question. All right, guys, I'm going to go through both of these. Well, actually, this question right here that I set up for you guys. I know I gave you guys both like two different versions of it, but both of the working for this question is the same up to the final part of the graph. All right, so that's why I wanted to show you guys side by side what this question is going to look like. So the first part here is rearrange. So x squared minus 6x plus 9 minus 1 is less than 0. So I'm going to get x squared minus 6x plus 8 is less than 0. So on the other side, exactly the same kind of step is going to happen as well, and we're going to end up with x squared minus 6x plus 8 is, the only difference is greater than 0. All right, so we factorize this. I told you guys, I gave you guys some real nice easy numbers to work with. So we should get minus 4 and minus 2. And then on this side, it's also going to be the same thing, x minus 4 and x minus 2. All right, so that means our solution, we're going to put that equal to 0, which means our solution is going to be 4 and 2. And on this side, it's also going to be 4 and 2. Okay, so what do we know about this particular graph? We know that it's a positive parabola. All right, so it's a positive parabola, which means it's going to look something like this right here. All right, and we also know that we're trying to figure out when is the parabola actually less than 0 and greater than 0. Now, don't get confused with it, because I'm actually looking at this part right now. This part is for the purple part. Sorry, purple part. Jeez, I'm getting colorblind here. For the blue part here, it's the quadratic less than 0. So that means it's going to be this part here. All right. And as for the other question, which is the green part here, it actually says when is the quadratic bigger than 0, which means above the x-axis. Okay. And we know what these 2 points are because we've actually calculated them. The smallest one being 2 and the second one being positive 4. Okay. So for the question on the left, that's the blue one. I can see that I'm actually looking at it between 2 and 4. So I'm going to write down x first and then 2 and 4 like that. And I'm going to point it to the point the arrow to the smallest number. All right. As for the right hand side, notice how it actually has 2 parts in green. All right. And so this is where it's not complicated. It's just one extra step that you got to do. So what I'm going to do is I'm going to kind of draw this shape again just to show you what it looks like. So there's my parabola. There's my 2 points right there, which is 2 and 4. And then my zone that I was looking at was the 2 green zones here. Okay. So for the second one, what happens is that I'm going to actually, because I have 2 green bars, I'm actually going to put the 2 X's at the end. Okay, trust me, I know this looks a bit funny doing it this way, but this is the way I kind of teach people and they just remember. But because there's nothing in the middle here, so I just put a little or, and then because it's basically saying that when the graph is above 4, so you can actually do it like this, or when the graph is less than 2. So this is how I kind of do my write-up. So basically, because there's nothing here, that ends up being or. The 4 ends up being there. The 2 ends up being there. The green zone, which is the X, ends up being here. And then what ends up happening is that literally that last line becomes your final answer for this second part of it. Okay, so is there any questions on that, guys? Because I want to put another question like that before going to that quadratic question that Jonathan posted. I just need to figure out a way how to actually bring it into my sheet, but I'll figure it out. If you have any questions, can you just pop up in the comments, please? Can we give x greater than and x negative 4 instead of... can you give x greater than 2 and x less than 4? Sarah, because you're saying and, I would probably give that because you're actually not saying or. So because you're saying and I think that's the key word is and. You're saying x greater than 2 and x less than 4. I probably would accept it. No worries, Matt. X squared equals -1. Haven't seen that in a while. Wow. Whoever put that up, I'm sure they're doing year 13 calculus. Get vexed. Okay, guys. So I'm going to give you guys one more question while I try and copy Jonathan's question here, which is another quadratic question. Great quadratic question. I'll bring it over soon. So this was the other question that I wanted you guys to try. But I'll just up the ante a bit. So we'll put that as less than or equal to 5. I think it is or because when do the signs? Jonathan, it is or. That's what I saw in the exam schedule. The reason it can't be and is because it's got 2 zones, so it could be true on one zone or the other zone. Selena, the signs flip when you divide by a negative number. So and particularly when you're dealing with quadratics, you generally won't have to flip any signs because you'll only be rearranging most of the time. So you wouldn't really have to flip any signs, Selena, unless it's a linear inequation. All right, while you guys are doing that, I needed to bring my question in. Okay, I'll just give you guys a couple of minutes to just work through that question. I'm just looking at his other question, and I'm trying to just kind of see how I can actually explain it. Okay, got it. All right, I think Jonathan's question is up. So could I give second one as x less than 2 and x greater than 4? Now, Sarah, I think it'll be better to write or for the second one. But let me just double check one of the answer schedules from last year because I remember seeing it as or and not and. But if in doubt, or is better because or means you can actually use both of them. Okay, anyway, let's get through this ugly looking quadratic here. I'm going to fly through this one, guys. So I do apologize about that one. So we've got rearranging it first. So 2x squared plus 7x minus 10 minus 5. And that is less than or equal to 0. So we've got 2x squared plus 7x minus 15 is less than or equal to 0. So straight away, we've got a quadratic equation. We know that. And we also know that it's a positive quadratic. So this quadratic is going to look like this. And we're trying to figure out less than or equal to 0. So we also know this, that this is the zone we're actually looking at right now. Okay, so all of that is done. So all you got to do right now is factorize this quadratic and find those 2 roots, and then you're good to go. So the way we're going to factorize this is we've got that really long-winded way of doing this. Now, guys, I had a question someone asked before. If you know how to use the quadratic formula, can you actually do that straight away? Yes, you can. It should be fine. But yeah, so I'm going to do it the old-fashioned way. So I got 2 times minus 15 is negative 30. So basically, I'm looking for 2 numbers that multiply to negative 30 and add up to positive 7. So in this case, we've got 10 and negative 3. So what I'm going to do is I'm going to split up this 7x as 10 and negative 3. So I've got 2x squared plus 10x minus 3x minus 15. And I'm going to put that equals to 0. And I'm basically going to factorize this. So do it by parts. So I've got 2x and then x plus 5. And then on this side, I've got minus 3x plus 5 equals to 0. Then because x plus 5 is a common factor, I've got x plus 5 and 2x minus 3 equals to 0. So 2x comes there, minus 3 comes there. And our x plus 5 is the common factor, so that's why it's actually outside. So once you do this, you've got x plus 5 equals to 0, or 2x minus 3 equals to 0. So in this case, I've got x is equal to minus 5, and in this case, I got 2x equals 3, x equals 3 over 2, or 1.5. Okay, so now that I've got my two roots, so I've got negative 5, and then I've got 1.5, and because I've got the zone that I already need, so I'm going to put down x, negative 5, and 1.5 like this, and just point them out to each other. Oh, I'm sorry, Eliana. Yeah, I kind of decided in the morning I had some time. Maybe I should actually put a little notification or something. I'll see what I can do the next one. Yeah. I think have I got that right? No, I don't have that right, and the reason I don't have that right is because if I look at the original question, it's actually less than or equal to, and so I need to make sure I put these two symbols here as less than or equal to as well. There you go. Yeah, thank you, Sajan. I was just kind of messing around just to see who was still awake. Not bad. Okay, guys. So this particular question, as I said to you guys when I actually was doing this live streams last year, I kind of had this crazy question that popped up, this idea that popped up. Maybe they'll create a question like this, and they did, which is the one that I did in the last tutorial last week Tuesday, which is basically dealing with exponents. All right, so sometimes they make it tricky by putting one of these quadratics in the exponential. So you just got to be aware of it. All right. Okay, so I'm gonna go to Jonathan because he's been word question of these would questions of these type of question. Sorry, Dominic. I think what you're trying to ask me is there word questions like these? There are word questions like these, but usually if you see word questions with inequalities, they will always have these kind of words like at most, at least, less than, more than. So these are kind of like the key words to keep in mind. Matt, great question, Matt. The reason I've done this question is I think I've just I picked the sign as it is, but this is for Matt Larson. You can actually get greater than 5, and I'll show you what that looks like. I mean, since you asked me, say for example the same question looked like this: 2x squared, was it plus 7x minus 10, and let's say instead of less than or equal to, it was greater than or equal to 5. Then what would happen is you still do everything the same, which means you're still gonna get your roots at minus 5 and 1.5. But just remember, because it's greater than or equal to, you'd be looking at it above the x-axis. All right, which means the final answer is going to be it's going to be x less than or equal to -5, or 1.5 less than or equal to x is greater than or equal to 1.5. Sweet. Okay, so let's I'm just going to go to this question, guys. I hope you guys can actually see it. Just screenshotted it. Let's see how it looks on my screen. Does knowing how to graph parabolas can help us out with these? Yes, but the only thing you need to remember, Aliana, is that if it's x squared, positive x squared, then it's a happy face, so you know, like your normal parabola. If it's a minus x squared, then it's upside down. I'll see how the time goes, Dominic. Dominic, if you've got a question, just pop it in. Oh man, what do I got here? Oh, sorry, you did send a question, Dominic. Let me have a look at that. Oh yeah, an exponent question. Yep, I'll see if, because that's a fairly easy. Ooh, I see. Okay, Dominic, I saw your question on Facebook. I'll do that after I actually do. Whose question is this? After Jonathan's question. All right. I also got another question from Selena. Sorry, Selena, I didn't see that. Yeah. Positive parabolas, happy face. Negative parabolas, negative, unhappy. Okay, so let's have a look at this question here. This is a lovely quadratic question that's a word question, but it's a bit misleading, all right? And that's the thing about all of these word questions, is that they always try to mess you around. So the first real important thing to notice here is that he's got a calf pen. Okay, what the hell is a calf pen? Well, that's this rectangle here. But the next part is the most important part, and I think it's this part right here with an attached square feeding area, which means the feeding area, the part that I've actually colored in blue, is actually a square. Okay. The calf pen is rectangular. There's a gate which separates the feeding pen from the calf. Yeah. The width of the calf pen is 4 meters longer than the length of the feeding area. Okay. So what we're going to do is we're going to do a couple of things here. We're going to put, let me choose a different color here. We're going to put the feeding area length, the base as length. Now, because it's a square, its height is also going to be length. What we know is the width of the calf pen is 4 meters longer than the length of the feeding area. So let me just see if I can get a different colored pen. So I'm going to do width of the calf pen. That's this part right here. Okay, it says that it's 4 meters longer than the length of the feeding area. Now, the length of the feeding area was what I said L was. Okay, so in other words, this part here is going to be L plus 4. Yes, these videos are available after I finish them, guys. It just takes like a bit of time to encode them, and then I've got a playlist up on my top of the chart somewhere for live tutorials, and you can find it there. All right, and what else do we have? The length of the calf pen is 3 times as long as the length of the feeding area. Oh, that's not too bad. So if it's 3 times the length, basically what we have is 3L. Okay, because that's what it says, is 3 times the length of the feeding area. Okay, the area of the calf pen and the feeding area combined is 112. How much fencing is needed to fence the entire area? Now, this is like, honestly, this is one of those annoying questions, because you do the hard part and then you forget that last part of this question here. All right, I've seen so many people do that, but let's see how we're going to do this. We've got the calf pen, all right, which is this thing here, which is the yellow highlighted calf pen, and then plus the feeding area, which is actually a square. So the area of the yellow rectangle and the feeding area equals to 112. All right, so now with the yellow rectangle, when I'm talking about the yellow rectangle, that's the calf pen. So the calf pen is this part right here. Let's just color it in, it's just easier. There we go, and that's the feeding area. So what we've got is, for the calf pen, we've got the base there as 3L, and then we've got L plus 4 as its height. As for the feeding area, we've got the base as L and the height as L. So we got area of a rectangle is base times height. So we've got 3L multiplied by L plus 4. I really should have used another letter than L. But anyway, here we go. And then we've got base times height, which is L times L, which is L squared, and that's equal to 112. So expanding the bracket, we've got 3L squared, and then 3L times 4L is plus 12L. Plus L squared equals 112. Apparently, but I don't know where this person found this question, but they did send it to me. And yes, it is. Looking at this question, guys, I would say it can be in an MCAT. It's not. It is at that correct level. So what we got is 4L squared plus 12L equals 112. Rearrange it. We got 4L squared plus 12L minus 112. It's actually not too bad, because the reason it's not too bad is all the numbers here are actually divisible by 4. Because you got 4L squared plus 12L minus 112 equals 0. You can take 4 out as a common factor. You get L squared plus 3L, and then 112 divided by 4. Man, trying to make me work. 120 is 30. So this has got to be 28. Equals to 0. All right. Once we get up to here, we can actually forget about the 4, because 0 divided by 4 is just 0. So what we have is L squared plus 3L minus 28 equals to 0. So now we've actually got to factorize this. So we're going to get two values. So we've got plus 7 and minus 4, and that equals to 0. Okay, because 7 times negative 4 is negative 28, and 7 minus 4 is positive 3. So at this point, we can actually see that L plus 7 equals to 0, or L minus 4 equals to 0. So in the first case, L is equal to minus 7, and in the second case, L is equal to 4. Sorry, just reading the comments here. Kelly, I'll be doing a level 2 later on at some point. Just gonna do the MCAT ones first for the next few weeks, and then after the MCAT, I'll start doing some level 2 and level 3 ones. Okay, so going back to this question, the first thing you guys need to realize is this. L actually can't be a negative value, okay? Because you can't really have negative 7 as a length here. But you can have L as 4. Okay, and I'll tell you guys right now, if you get up to this stage here and actually say L has to equal 4, I believe you will only get a merit. Now, the reason you'd only get a merit is because if you go back to the question, this is the actual question right now. How much fencing is needed to fence the entire area? Okay, so let's have a look at it. So what we have is, I'm just going to have to draw this again. So we've got the calf pen here. And then we've got the feeding area here. All right, so what we do know is that L is equal to 4. And because L equals to 4, I'm going to, the fencing area has to go around, right? So I've got 4 there, 4 there, 4 there. I also know that the top part of it is 3 times L. So 3 times 4 is 12. And then on the sides here, I've got L plus 4, so that's going to be 4 plus 4, or 8. So that's also going to be 8. Now, the part in the middle, just remember that it's actually 3L. And we already have 1L here. So I'm going to go back to this diagram. So if you guys have a look here. So this is already 1L, this is an L, this is an L. That's how the 3L comes through. So I've got 4 here, 4 here. And if I think about the fencing part of it, I only need to fence this, this part, this part. Those are the parts that I actually need to fence. Which means the final answer for this is going to be, I'm going to start from a point and go around. So I'm going to start here and go this way. So I've got 8 plus 4, 12, plus another 4, geez, 16, 20, 24, 24 and 4, got 28. I'm struggling today. 28, 36, and then we've got plus 12, 48. I'm hoping it's 48 because otherwise I'm gonna go throw myself for a sleep. So yeah, so the final answer there is 48 meters of fencing is actually required. That's what, wait, I thought the feeding area was completely fenced off. Okay, let's go back to the question. I think they say there's a gate there. So there's already a gate at this, there's a gate here, so we don't really need to fence the gate. Okay, sorry guys, just going through the questions. What did I miss? I love that I'm getting job offers. Happy level 2. Did I mock exams? No, don't need it. MCAT mock, Swedish flag. Level 2 algebra. Kelly, I'm going to be putting up a whole lot of level 2 stuff up on algebra, so keep an eye out for it. Lewin, I think we've answered your question. Jonathan says that's correct. I hope he's meant the answer is correct. Okay, cool. We're good. Let's go to the next part of the question. I think man. Okay, I'm going to show you guys this question here, which is another quadratic question. Copy image. Let's see if this picks up. Let's see if this has come up. Yes, it has. Awesome. All right, guys, I'm going to do this question next. Do you have any tips on if word choice in a question can give us a hint on what kind of formula working out what we have to do? Okay, I'm gonna try and work on this question, guys, and then I'm gonna come back to the comments later on. This was actually sent to me on Facebook by somebody, so just trying to answer this question. I did do this question. It's actually 2015 MCAT paper. Okay, what I'm gonna say to the person that actually sent me this question is, just have a look at my playlists. There is a 2015 MCAT exam paper that I actually did, so I just don't want to do the same question again, but go just look up 2015 MCAT. I can't remember which day it was, but if you have the paper with you, just look up that video and then you should be able to find it. Okay, I'm gonna go to the next question. This one here is a good question here. Where is it? WX, jeez, what? Oh, okay, I see. Okay, this was a question, another quadratic question that was sent to me by someone here. We're gonna call it question D. We got W to the power of X minus 2 over W2X. What the hell? WX. Actually, this is not a quadratic question. This is more like this is a straightforward Yeah, so basically I'll do this question, guys. This is just a straightforward linear question, all right? Because all you have to do is just rewrite this as, because w is got the same base, you just rewrite this as w to the power of x minus 2. And remember, when you have two bases that are same and when you divide them, you subtract the powers. So this is going to become minus 2x, and all of this is equal to wx. So what ends up happening is you've got w, x minus 2x is negative x, minus 2 equals wx. And because the two w's have the same base, you can actually say the powers are equal to each other. And so what you're going to get is negative x minus 2 equals x. Rearrange it. Minus 2 equals x plus x. And you've got 2x equals minus 2. And then x is equal to negative 2 divided by 2, which means x equals to negative 1. Let's see. What are the questions? Can you use some of the excellence question from 28 MCATs after? Matt, I've actually got a video for 2018 exam papers, so just have a look at the 2018 exam papers for the excellence questions. How impossible is it to pass the MCAT in level 1? Chelsea. The exam paper is actually, I would actually say it's not too bad. I know people kind of make it a bit crazy as it is. I would actually say that it is definitely possible. In fact, I think if you have the basics, like, let me put it this way, guys. I know some people actually get stressed out about the MCAT, but the reality is this. Like, I mean, I've actually worked with kids where they've not passed the MCAT, but they've actually gotten through level 2. They've passed level 2 algebra. All right. I think, and that's the same thing that goes for tables, equations, and graphs as well. Now, last year's exam paper was just absolutely horrible. It took me so long to actually get the exam paper into a video, and it was just horrible. So I would actually say just get the basics sorted, and once you get the basics sorted, you know, like most of the schools, I think they say like you got to either get a merit or an achieve to actually do level 2. So I think just keep that in mind and just keep practicing. That's all you got to keep doing. Yeah, as Aliana is saying, you know, the best thing is just work on the basics. And believe it or not, like a lot of questions come through and it's actually not too bad. You can actually kind of get it done. Okay, so we've got time for another couple of more questions. I'm just going to check if there's any more people. No, they have not put any more questions. All right. How much of level 2 algebra builds on MCAT skills? Sarah, the best thing is just make sure you know your quadratics and your exponents. Because in level 2, that's the most kind of important thing that you kind of mess around with. Is like a lot of quadratic stuff you repeat, and you do a lot of exponent questions, like lots. The thing how you have to keep your equal sign above each other is really annoying. Yeah, not sure how I can help you with that. Okay, so let's see. What other questions did I say that I was going to put down? We've got quadratics and rearrange. Okay. Just to kind of do a couple of rearranging questions. What I'll do is I'll just look for this particular rearranging question, which came about a couple of years ago, I think it was. We'll just make up one. Here we go. Okay, so let's say we got this question right here. A equals to 9 pi squared over x. Some weird question like this. And they actually say rearrange so that make x the subject. All right. When they ask you guys to rearrange and make something the subject, Usually it's like a letter they're saying, so what you want to try and do is just have the letter by itself. That's the whole purpose behind rearranging. So in this case, what I've actually got is I've got a equals square root of 9 pi squared over x. Now I got to get rid of that square root symbol. So if I want to get rid of the square root symbol, the first thing that you need to remember is the opposite of square root is squared. So I'm going to square both sides. All right, remember in algebra is that whatever you do to one side, you pretty much have to do it on the other side as well if you want to keep the equations balanced. So in this case, what's going to happen is it's going to end up looking like this: a squared over 9 pi squared over x. Okay, because I have actually taken the square root of it, got rid of the square root. So next thing is rearranging it. So I've got to bring x by itself. So when I cross multiply, what's going to happen is I've got a squared multiplied by x, and that's equal to 9 pi squared. Now I've got to get rid of the a squared, so I'm going to end up leaving x there as by itself, and I'm going to get 9 pi squared over a. All right. Let me just have a quick look at any more. Okay, we got another question, a couple of more questions. All right. Okay, Dominic, I picked up your question. Give me a second, mate. Okay, so this is not a rearranging question, but it's a very unique question in the way it's solving. So I'm going to do this one here. So what we've got is, I'm just going to put another example here. I'm going to do the last question that you actually sent me, Dominic, because that's I think that kind of covers quite a few of the topics. Oh, 3 over 2. A squared, did I get it? Sorry, yes, thank you, I missed that. Thank you, Sujan. Selena, no, because we're multiplying with the x. Yes, sorry, Carol, fixed it. Thank you guys, sorry. Now the x doesn't, it's only when it's actually plus x that Selena will actually have to go through some of the rearranging questions, and I'll show you the difference why that it doesn't become a negative x. Okay, so this was a question that was actually popped up. Now this is a really kind of like a neat question because it actually covers quite a bit of things that you need in terms of rearranging. So what we have is we've got a inequality. Not only do we have an inequality, we also are dealing with a fraction as well. Okay, so what I'm going to tell you guys is this: whenever you see a question with a little negative symbol like this in front of a fraction, all right, the first thing I want you to do is put a bracket around 2x plus 1. All right, this part is really important, because this bracket here is going to save you a hell of a lot of grief later on, because putting this bracket at the beginning is going to help you get either it could be the difference between getting an excellent sometimes or an achieved. That's how important this bracket is. Okay, so anyway, how do we actually go about solving this question? Now we've got 4 in the denominator and we've got 3 in the denominator, and straight away we can say that between 4 and 3, 12 is the common factor. All right, so that means what I've got to do is I've actually got to multiply. Sorry, I'm just going to rewrite this equation just with a bit more space. So I've got x over 4 minus, I'm going to put that bracket, which is 2x plus 1 over 3, greater than or equal to 3 over 2. All right, so between, for the first fraction, x over 4 there, I know that 12 is the lowest common multiple that I want. So I'm going to multiply the denominator by 3 and the numerator by 3. And as for the 2x plus 1, what I'm going to do is I'm going to multiply by 4 in the denominator and the numerator by 4. Okay? So when I do this, what I get is 3 times x, or x times 3, is going to be 3x over 12 minus, and what I'm going to do is I'm actually going to write 4 in the front here, and I'm still not taking it out of the brackets. And I'm going to write it like this: 2x plus 1 over 12 is greater than or equal to 3 over 2. Okay? Now that the denominators are the same, I can actually put everything under 12. And I can rewrite this as 3x minus 4 times 2x plus 1 greater than or equal to 3 over 2. Now remember, at the beginning I told you guys, make sure you put the bracket. The reason I asked you guys to put the bracket is because if you don't put the bracket, I guarantee it, this is the mistake people end up doing. They actually have the same everything as is, but instead of doing it as, they would have actually done it like this, or some variation of this. And what they end up forgetting is that sometimes people do it like they go, oh, negative 4 times 2x is 8x, but then negative, like they write it as positive 4, or sometimes they just leave it as 1. Okay, so that's why it's really important to put that bracket there, because when you put that bracket, see what happens. I go negative 4 times 2x, which is negative 8x. Negative 4 times 1 is negative 4, and the whole thing is over 12, greater than or equal to 3 over 2. So now what I got is 3x minus 8x, which is negative 5x minus 4 over 12 is greater than or equal to 3 over 2. Now here's a bit of a shortcut that you can do. If you're, well, no, actually, no, you can just do this as it is, because you can just go negative 5x minus 4 is greater than or equal to 3 over 2 multiplied by 12. So going back to you, Selena, remember we talked about taking x to the left, won't it become a negative? So see, in this case, because on the left hand side, the 12 is it's being divided by, so when I bring it over, it actually gets multiplied by 12. So the symbol doesn't change there, because at that time we're actually looking at divide and multiplication. Okay, so what we have is negative 5x minus 4 greater than or equal to, well, I'm just going to write that as 1 and 6. So 6 times 3 is 18. Rearranging this, I've got minus 5x greater than or equal to 18 plus 4. And then we've got minus 5x greater than or equal to 22. Now, here comes the kicker. All right, the kicker is this. We've got x has, it has to be, because you're dividing by negative 5, this is the part where your symbol actually needs to change. All right, so whenever you divide by a negative number with inequalities, the symbol actually switches over. Can't you multiply negative 5x minus 4 by 2? Kushi, yeah, you could do that too if you want to. It's just like, I mean, from that stage here, I'm talking about, what is it? From this stage, you could do like so many different ways. You could cross multiply. You can, you can make the denominators the same and then kind of rearrange. Yeah, there's just like so many different ways you can actually do it. Okay, so if I was to cross multiply, this is what would have happened. So what would have ended up happening is 2 multiplied by negative 5x minus 4 greater than or equal to 3 times 12. And guys, you're still going to get the same thing, because look, 2 times negative 5x is negative 10x. 2 times negative 4 is negative 8. Greater than or equal to 3 times 12 is 36. All right, so you got negative 10x greater than or equal to 36 plus 8. You got negative 10x greater than or equal to 44. And then x is 44 over negative 10. Switch the sign. But of course, 44 over 10 is the same thing as saying 22 over negative 5, which is the same answer. Sorry, Scott. Let's just fix that for Scott right there. So we're going to go x is less than or equal to negative 22 over 5. There you go, mate. I was getting to the negative 22, folks. Yeah, coming down for a visit, Dominic. You can. I mean, I think this is fine. I don't think you can actually simplify any further than that. But Jonathan, I would probably say it's a good idea to just simplify as far as you can. Oh man. Okay. All right, guys. It's 10 o'clock. That's basically it from me. Why did he flip the signs? Matt, I flipped the signs because I divided by a negative number. That's why whenever you divide by a negative number with inequalities, you've got to actually change the sign. Come and teach in Wellington. Nah, Dominic, I got some family there, man, but life here in Auckland so far is all right. Guys, that's basically it from me for today. What I might do is I'll see if I can run another one, but Alyana, I'll try and see if I can get it organized a little bit earlier. All right. I'll hang around for another 5 or 10 minutes. So if people have any questions, just some generic questions, don't make me do any problems, but generic questions, I'm happy to help out. What if it's a positive number? Do you still change the inequality? No. Legendary R, if you're dividing by a positive number, you do not have to change the inequality. Chinmay, I will be uploading. Is there a way to upload questions and you can solve on video? Yes, you can send a picture to my Facebook Messenger. Yeah, so just look up. Let me see if I can get a link for you guys. Where is it? Where is it? I'll just share a link to you guys so you guys can actually just ask questions there. Wrong bloody thing. So Chinmay, there's my Facebook page. So it's just take a screenshot of the questions and just send it to me there. What if you multiply by a negative? Do you still switch the sign? Yes, you would. AEVN, no, AVN, not back. Just the only thing you need to worry about is like when you divide by a negative sign. Until then, you treat it like a normal equal sign. Kevin, I'm thinking Tuesday. I'm thinking Tuesday night, 9 to 10. I'll see how the day pans out. Because usually Tuesday is my busiest day. If I'm shattered, then I can't do it. But I'll try and be here around 9 to 10. I'll definitely try and do a couple next week. Because I think you guys got how many more days? Is it 15 days for the MCAT or 2.5 weeks? Yeah. So 2 weeks. Okay. Yeah, I'll try and do a couple later on. Why is there a 6 on top of the 12? Did you simplify it? Selena. Selena, is just a quick way to actually do, if you want to multiply big numbers. So say, for example, you do something like 10 over 3 times 12. Jonathan, your call, man. Like, because sometimes I'm stuck for topics, what to do, because I need to find questions. That's the hard part. like I struggle for time for finding questions, but if you guys give me questions, then I can kind of group it up and then just kind of cover things. So if you have like some simultaneous questions, I think you posted one just now, but yeah, I just need to figure out how to flip that image sideways on my laptop, but I'll figure it out later on. Yeah, so it's up to you guys. Just keep dropping messages on the Facebook page, and then if I have some time, I can just make like little videos. But then I think next one I really should be covering some basics in simultaneous equation. Sorry, Selena, going back to you. I keep getting distracted. So if you have this question like this, right? 10 over 3 times 12. So, I mean, the long way of doing it is like you'd go 120 divided by 3, which then equals to 40. The other way you could do it is, because, 12 is a multiple of 3, so you basically could just go, so you take this 3 here, divided by 3, it becomes 1. But when you do 12 divided by 3, it becomes 4. It's almost like kind of looking at it and saying which one has a common factor in the numerator and denominator that you can actually cancel out. And then straight away from there, you can just go 4 times 10, which is 40. It's just kind of like a quick way of doing it. Okay, guys, that's basically it from me. I will upload this video shortly. Thank you for joining, and I'll catch you guys next time once I figure out how to stop this stream. I think it's here.